At 2 a.m., one of our content pipeline runs failed on node 6 of 6. The transcript was fine. The research notes were fine. The final upload metadata was nonsense. Wrong title, wrong thumbnail, wrong publish flag. The naive fix was to run the whole thing again. That meant 40 minutes of model calls, video processing, and API traffic, just to maybe reproduce the bug. Worse, the second run produced different text, so we were debugging fog. That night paid for my durable execution rule. Every edge in the graph gets a checkpoint, or it is not production. Most first agent graphs are optimistic. They keep state in memory, pass a dictionary from node to node, and log a few human-readable strings. That works until the process dies, the model returns a malformed object, or an external service times out after doing the work. Then your choices are bad. Start from zero and pay again. Patch the database by hand. Or guess which node damaged the state. Plain logs help, but logs are not replayable state. A log says, I summarized the source. A checkpoint says, here is the exact typed state the next node received. Durable execution starts when you treat that difference as operational, not cosmetic. The pattern is checkpoint at edges. At every node boundary, store a snapshot containing the full typed state, the node identifier, the timestamp, and a checkpoint identifier. I prefer edge boundaries over random mid-node saves because they give you clean contracts. This is what entered the node, and this is what left it. Replay does not mean rerun the whole workflow. Replay means load checkpoint N and continue from there, with the same graph code and a controlled policy for external actions. If the run has 6 nodes and node 5 broke the state, you should be able to start at checkpoint 4, not burn nodes 1 through 3 again. Mechanically, this is simple. Before a node runs, the orchestrator loads the latest checkpoint for that run and node position. The node receives a type of state object, not a mystery bag. After the node succeeds, the orchestrator writes a new snapshot. Run identifier, node identifier, sequence number, timestamp, schema version, and full state. That checkpoint identifier becomes your audit trail. When someone asks why the system posted a particular title, you point to the checkpoint chain, not a shrug. On replay, you choose a checkpoint identifier, restore its state, and resume the graph from the following edge. Opinionated note: save complete state first. Optimize to deltas later, after correctness is boring. Take a content pipeline. Node 1 gathers sources. Node 2 writes an outline. Node 3 drafts the script. Node 4 renders assets. Node 5 uploads the video. Node 6 schedules the post. After each node, we persist the full type state, source URLs, claims, script sections, render path, video identifier, metadata, and validation results. A run fails because node 6 schedules the wrong publish time. I load checkpoint 5, inspect the state, and see the upload result is good. Then I replay only node 6 with a dry run flag. If the bad time appears again, the bug is in scheduling. If it does not, I compare checkpoint 5 from both runs and look for the first field that changed. The sharp edge is side effects. Replay runs code. If that code posts, uploads, sends email, charges a card, or opens a ticket, replay can do it twice. Durable execution without idempotency is a duplicator. Every external action needs an idempotency key derived from stable business identity, not a random retry identifier. In my upload step, the key includes the video identifier and action name. Before posting, the step checks a ledger. If the video is already uploaded, it returns the existing result instead of sending again. Limits still exist. Non-deterministic model calls may differ. Old schemas may not load, and secrets should never be stored inside snapshots. This sits right in the graphs tier, because graphs make failure location visible. A linear script can hide where state changed. A graph with node boundaries gives you places to checkpoint, diff, retry, and cut off. Durable execution connects to state schemas because snapshots must be typed. It connects to verification because each checkpoint can include validation results. It connects to budgets because replay from N saves tokens and wall clock time. It connects to orchestration because the runner, not the node, should own checkpoint rights. And it connects to auditability because checkpoint identifiers become the spine of the run history. Here is the 10-minute version. Pick one automation with at least 3 steps. Do not redesign it. Wrap each step with 2 functions: save checkpoint and load checkpoint. Save a JSON file or database row after every step with run identifier, node identifier, timestamp, schema version, and the full state. Then intentionally fail the last step. Restart from the checkpoint before that step and prove you do not repeat the earlier work. Finally, find one side effect in the workflow and add an idempotency key plus a tiny ledger table. The goal is not a perfect platform. The goal is to feel the difference between rerun from zero and replay from a known boundary. 3 beats to keep. First, snapshot at node boundaries, full type state, node identifier, timestamp, and a checkpoint identifier. Second, debug by replaying from checkpoint N and diffing snapshots until you find the exact node where good state turned bad. Third, treat side effects as dangerous during replay. Uploads, posts, and sends need idempotency keys and a ledger, or your debugger becomes a duplicate action machine. This is not glamorous infrastructure, but it is the difference between guessing at 2 a.m. and proving what happened. New loop engineering episode daily on this channel. Build loops that finish, verify, and stop.